All right, today we're going to continue to work with exponent laws as well as adding to it scientific notation that you learned yesterday. Here's the deal. I'm letting you have a calculator today, but don't abuse that. I understand that you can type scientific notation into your calculator, and if you don't know how, don't try to figure out how. Because if you don't have work shown, I'm taking your calculator and I'm not giving it back. Okay? I can make you multiply this stuff out if I really wanted to. I'd rather not. Okay? So only put in there what I ask you to. So we're going to use the product of powers, multiplying with exponents, and quotient of powers, dividing with exponents, to multiply and divide numbers in scientific notation. So it says to evaluate, and our answer has to be in scientific notation. Everything has to be done in scientific notation. When I have two parentheses right next to each other, what operation's happening here? Multiplication. Okay, just like last week when we multiplied with coefficients and with different variables, we want to regroup this. We want to put our front factors or coefficients together, and we want to put our base 10s together. So we would group together 7.2 times 1.6 and 10 to the third times 10 to the fourth. Now, you actually get to multiply on this. Grab your calculator, and I'm totally fine with you multiplying this. 7.2 times 1.6 gives you 11.52. When you multiply, you keep the base and add your exponents. 3 plus 4 is 7. Now, from yesterday, is this proper scientific notation? How do you know? What does proper scientific notation mean, Jack? How many do we really want? 1. So right now we cannot circle this because this is not proper scientific notation. So I'm going to show you a dash diagram, and people this morning were like, oh yeah, I get it, and then they quit using it and they got them wrong. So right now I have an exponent of 7. Whoopsies. An exponent of 7. And a positive 7 really means that I have 7 decimal movements to the right. So a dash diagram would say, here's my decimal, but I really should move it 1, 2, 3, 4, 5, 6, 7 to the right, because my exponent tells me that. Now, Jack is spot on. I cannot have 11.52. So what direction do I need to move that decimal so that I am proper? To the left towards Weiss or the right towards Hoosier? If I move it to the right, does that give me one number in front of the decimal? How many numbers are in front of the decimal now? 3. So which direction do I need to move it? To the left. How many numbers are in front of it now? 1. Whatever I do in that number, I also do in the dash diagram. So I'm going to move my decimal to the left, which leaves an open swoop, which means I need another dash. So the number was 11.52. You just moved the decimal to make it 1.152. How many dashes do you have now? 8. 1.152 times 10 to the 8th. And I'm going to tell you, you have to understand this dash diagram. Don't try to figure it out in your head. Write it out. Visualize it. Questions so far? Okay. Number 2. 2 parentheses next to each other means I am multiplying. So we regroup. We put our front coefficients together. 8.4 times 2.5. And, whoopsies, 10 to the second times 10 to the sixth. So we actually multiply our numbers out front. And we get 21. What do you do to your exponents? You add them to give you 10 to the 8th. Hey, on 21, where is my decimal? At the end, like here. So with that, are we proper scientific notation? No. How many numbers are in front of the decimal? 2, and I can't have that. So now I need to create a dash diagram. How many dashes do I have? 8. So I have a decimal. 1, 2, 3, 4, 5, 6, 7, 8. I only want one number in front of that decimal. Which direction am I going to move that decimal? Left towards Weiss. Do the same thing in your dash diagram. When I leave that open swoop, it tells me I got to put a dash there. 21 became 2.1, and 10 to the 8th became 10 to the 9th. Nicely done. Nicely done. Notice everything is in scientific notation. We're not writing huge, massive numbers. Everything is done scientific notation. Okay, let's look at 3. In 2010, the world population was 6,860,000. The population of the United States was about 3 times 10 to the 8th. About how many times larger is the world population than the population of the United States? Now notice they tell you that the world is larger, correct? So they want to know how many times larger. They say the world is equal to what number times the US. Follow me so far? I need to figure out what this number is. Think about this like solving an equation. If I want to get that yellow box all by itself, what should I do? Why would I divide, Calix? Bingo. Right now we're saying some number times the US population. We would have to divide by the US, because then they would cancel, and divide by the US. That tells us how to set our problem up. We need to take the world population and divide it by the US population. Okay, but what do you hate about the world population? It's so big. Let's rewrite it. Use your skills from yesterday to write 6,860,000,000 with proper scientific notation. How do I rewrite that number? What's it look like for scientific notation? Anybody? Rewrite this number in scientific notation. Brant, what'd you write? Times 10 to the... Anybody else? Good work. I like it. Okay. What is the US population? 3 times 10 to the 8th. Now, up above, we multiplied, and we grouped our front numbers together, and then we grouped our base 10s together. Now we're dividing. Guess what? We're still going to do that. We're going to group 6.86 divided by 3 and 10 to the 9th divided by 10 to the 8th. Guess what we're actually going to do to these two numbers? You're actually going to divide them. Your front numbers, you actually divide. 6.86 divided by 3, and if I remember correctly, it's a long, nasty decimal. 2.286. So let's go to the round to the nearest hundredth. 2.229, right? Is that right? Yeah. Okay. Then what do I do to my exponents when I'm dividing? I subtract. 9 minus 8 is 1. Now, on all of these other problems, Ms. Hoff stopped you and said, is this proper scientific notation? How do you know? There's only one number. Guess what? We're done with that problem. So not always do we have to move our decimal with the dash diagram. Sometimes it winds up okay. The surface of Lake Superior, the largest of the Great Lakes, is 8 times 10 to the 4th square kilometers. The surface area of the smallest Great Lake, Ontario, is 18,160 square kilometers. About how many times as great is the area covered by Lake Superior than Lake Ontario? How many times as great is Lake Superior? So Lake Superior is larger. Lake Superior is what number times Lake Ontario? So if I'm trying to solve for what this number is, what do? divide by Lake Ontario on both sides. So I need to take Lake Superior and I need to divide it by Lake Ontario. What's Lake Superior? 8 times 10 to the 4th. And looking at Lake Ontario, what's Miss Hoff going to tell you to do right away? Scientific notation. Will, did you already rewrite it? Anybody rewrite it? Calix, what'd you get? Anybody else? 1.816 times 10 to the 4th. Good work. Okay, now we're going to separate them off. 8, we're going to divide 1.816. And 10 to the 4th, we're going to divide 10 to the 4th. Actually divide your first two numbers, and I think it's nasty, down to like the nearest hundredth. 4.41. Anybody else get 4.41? Yes? What's after the 0? 5. Yep, so then your 5 would round up. Yep. Then we keep our base and we do what to our exponents? What's 4 minus 4? 0. Now here's the question of the hour. Some of you got this wrong on your quiz. Anything to the 0 power is 1. Not 10 to the 1st, just plain 1. So really this is 4.41 times 1. Well, what is 4.41 times 1? 4.41. So Lake Superior is about 4 times larger than Lake Ontario. Multiplying and dividing, very straightforward. You just have to make sure your final answer has proper scientific notation. Okay? Now, we multiplied, we divided. What operations haven't we done? Adding and subtracting. Flip it over. If I said no calculators and I wanted you to take 17.31 plus 4.2, and I'm going to make you do it on paper, what would be most important about setting that problem up? You put a 0 behind 2 and somebody over there said it. You got to line your decimals up. So the same rule applies when we're dealing with scientific notation, because remember, those are really, really big numbers or really, really small numbers. We still have to make sure our decimal and our place value lines up. And we do that by matching the exponents. So here's the twist on adding and subtracting. The very first thing you have to do is match your exponents. Then you get to add or subtract. Then we'll worry about proper scientific notation. I'm not going to lie to you, adding and subtracting is a little bit more work. Okay? On 5, what are we doing? Adding or subtracting? Adding. Number one thing Ms. Hoff said is we have to match up our exponents. What do we currently have as exponents? Exponents. 3 and 4. 10 to the 3rd, 10 to the 4th. Does Ms. Hoff care if you pick 10 to the 3rd or 10 to the 4th? No. Which one do you want? 10 to the 3rd. Okay? So we're going to leave 8.41 times 10 to the 3rd. But I need to rewrite 9.7 times 10 to the 4th with something times 10 to the 3rd. So right now my dash diagram has 4 dashes on it. Whoopsies. Because I have 10 to the 4th. But you guys told me you want to move it to 10 to the 3rd. What do I need to do with this decimal so that I only have 3 dashes? Move it to the right. If I push this decimal 1 slot over, I no longer have that dash. Whatever you do in the dash diagram, you do to your number. So put your pencil on that decimal and move it 1 to the right. 9.7 becomes 97 times 10 to the 3rd. Now we reached our goal. We have matching exponents. Now we're going to regroup this. 8.41 plus 97. And we got 10 to the 3rd to match, so we're just going to drag down 10 to the 3rd. Biggest mistake people have made today is right here. They forget to put the plus sign and they want to go and multiply. Don't multiply it. So add them together for me. 8.41 plus 97. 4-1 times 10 to the third. So my question is, do we have proper scientific notation? No. So we draw a dash diagram. How many dashes are in this diagram? 3. To make 105.41 proper scientific notation, what am I going to do with my decimal? Move it to the left, how many? 1, 2. So in my dash diagram, 1, 2. What do I put in those swoops? Dashes. So 105.41 became 1.0541, and 10 to the third became 10 to the fifth power. Nicely done, you guys. So the difficult, I shouldn't say difficult, the part where people get frustrated is you have to match your exponents first. Okay, so on that one, you guys went to 10 to the third, which is smaller than 10 to the fourth. Let's try going to the larger one. Okay, on number 6, we have 1.263 times 10 to the ninth minus, notice we're subtracting here, 1.525 times 10 to the seventh. So the larger exponent is which one? 10 to the ninth or 10 to the seventh? 10 to the ninth. So let's leave that guy. 1.263 times 10 to the ninth. We're going to leave him. Now, the other one is 10 to the 7th. So in my dash diagram, I have 1, 2, 3, 4, 5, 6, 7 dashes. How many dashes do we want to change it to? 9. So what am I going to do to my decimal? Move it to the left twice, so like this. Is everybody good with that? What do I do in those open swoops? Put 2 more dashes. Are there 9 up there now? So do the same thing in your number. So if I move it to the left twice, my number really becomes 0.01525 times 10 to the ninth. Winner, winner, chicken dinner. We have 10 to the ninth, so we can rearrange this. 1.263 minus 0.01525. And I'm going to steal 10 to the ninth. Now you guys know I'm terrible at subtraction, so hopefully somebody's going to help me out here. Anybody second him on that? 24775? Yes? Times 10 to the ninth. Okay, question of the hour. Proper scientific notation? Yep. Boom, that's nice. We don't even have to change that one. What do you hate about problem 7? Huh? Big number. What should it be written with? Scientific notation, correct? So the first thing we need to do is we need to rewrite that number. Everybody take a minute and rewrite 2,700,000 as scientific notation. All on you, Ray Among Us. You got this. You got this. Where do you want me to put the decimal? Good thing you got Brant helping you there. Oh, you knew that. Okay. Oh, okay, okay. Times 10 to the, don't tell him. Anybody? Which one? Is it 5 or 6? 6. Do you guys agree with him? Can't believe you guys told him 5. Wow. Yeah, way to go, Sage. Okay, you guys do this one on your own. I'm going to check in with you in just a minute. I don't care if you go 10 to the 5th. I don't care if you go 10 to the 6th. Add these two together. What'd you get for an answer? You should have gotten 3.33 times 10 to the 6th. Now, I'm going to show you both ways. It doesn't matter which way you did this. On the left, I changed them both to 10 to the 5th. So 6.3 times 10 to the 5th stays. But if I want this to be 10 to the 5th, I need to move it to the right. So 2.7 becomes 27. I add 6.3 and 27 and get 33.3, and I keep my 10 to the 5th. But I need to move my decimal over, which adds another exponent on there. So 3.33 times 10 to the 6th. Over here, I decided to go to 10 to the 6th. So 2.7 stays. But if I want 10 to the 6th, I need to move my decimal to the left, which becomes 0.63. 0.63 and 2.7 is 3.33 times 10 to the 6th. And that's proper, so I don't have to change anything. The biggest thing that people are doing is they're matching the exponents, and then in this step right here, they're multiplying. So just be really aware that whatever happens up here is also what happens in that step. Okay? Now, quick reflection, quick review. When you multiply and divide, which was what we did on the front of this paper, do you have to match the exponents at the start? No. When you add and subtract, which is what we did on the back of the paper, do you have to match the exponents before you add or subtract? Yes. Okay. I'm going to let you get started, and then I will be around to check as you go. I have a worksheet for you.